discuss about the heap sort. Start with the definition. Heap sort is a sorting technique that uses a special tree structure called a heap to sort elements. Okay, we form the heap tree first, then perform the sorting operations. Okay, what is heap? Heap is a complete binary tree. What is binary tree? In each node can have at most two child nodes, binodes. Okay, so then this tree is called binary tree. Likewise, so parent node is there, then two child is there. One is left child and another one is right child node. So this structure is called binary tree. So a heap is a complete binary tree. Okay, so two type of heap is there. One is min heap, another one is max heap. What is min heap? Parent node is smaller than child node, means that it min heap node. Parent node is greater than child node, means that is max heap. So this is the complete binary tree, right? Each parent have two child, one is left and one is right. This is the complete binary tree. So this is called heap. In min heap, parent node is less than the child node. So here parent is 10, child is 20, 30, right? So this is minimum value. And here this is minimum. This parent is minimum. This parent node value is minimum than the lesser than the child node, right? 40 and 50. Likewise, 30 is less than 60 and 70. So this form, this structure is called as min heap. In max heap, the reverse of min heap. Here the parent node is higher than the child node. So 90 is higher than 70 and 50. Here 40 and 30. So 90 is higher than 70, 50. Here 70 is higher than 40 and 50. Here 50 is higher than 20 and 10. Right? So here parent node is always greater than child node. In min heap, parent node is always lesser than child node. Clear? Okay. How to perform heap sort? So here we using heapify method. First two step is there. So two important step is there. One, we need to build max heap tree. And then perform the delete operation. So delete the elements one by one from the heap tree. So then the deleted elements added into the separate array. So finally we got the sorted elements. Okay, so I will explain with one example. So first step is build max heap. Okay, this array contain 5 elements. We build the max heap first. This is first step. What is the first element in the array? 15. So we take this 15 as a parent node. Okay, we insert the node one by one. First insert, we create the parent node and left, then right, then left child, then left, insert the element in left and complete the binary, complete the two child, left and right, then move with the next element. Okay, next node. Okay, likewise. 15 is first element. Okay, we make this 15 as a root node. In second step, what is the second element? 20 is the second element. So what is the procedure? We insert that element in the right side of the parent node. Left side of the parent node. And then only we insert the element in right side. Okay. So 15 is the parent node and insert the second element in the left child of the parent node. Create. Then check one more condition because we build the max heap, right? So in max heap always the parent node is greater than the child node. So just check it out here. Parent node is greater than child node? No, right? Parent node is less than child node here. So parent node is not greater than child node. So perform the swap operation here. Swap these two nodes. Okay, swap these two nodes. So this is the final. Then step 3, what is the third element? 7 is the third element. Then add 7 with the right child of the parent node. So this over. Then after we check one more time, the parent node is greater than the child node. Here the child is 15, 17 is greater than parent node. So no problem, no swapping is needed. Okay, clear? Then what is the next element? That is 9. Then next, where we'll add? So we add the left child of this node. Okay, left child of this node. the complete left and right node of this child, then only this node, then only move to 7. Okay, this is the order to insert the node in max heap. First parent node, then complete the left and right of the parent node, then insert the node in left side and complete the both child, then move to the right. So this is the procedure to insert the node in the heap, max heap. Okay, so then what is the fourth element? That is 9. So 9 is insert into the left child path. So 9 is inserted here. Then again we check the this parent node is greater than the child node. Here 9 is greater than 15, no problem. So we already checked. So no swap will need. So next element is 30. So 30 is inserted in this position. Okay, complete this level, then only move to 7. Okay, then insert in this place. Now check the max heap property. So here 15 is less than 30, right? Then swap these two nodes. Swap this node. So 30 and 15. And one more time you check these two elements, because this is the parent of this node. Here 30 is so this parent is less than 30, right? Then swap these two node also. So this is the final max heap. Okay, so two important things you keep in your mind to build the max heap. First, inserting order of the node in the tree. So first insert the parent node, and second and third element insert into the left and right child. First insert in the left side, then move to the right side. Then start with the left child, complete the left child node, then move to the right child. So this is the ordering how to insert. This is the order to insert the node in the max heap. Then in every insertion, after every insertion, we check the particular tree structure is in the max heap. Verify the max heap, confirm the max heap property, right? What is the max heap? Always the parent node is greater than the child node. If this property is not there, means we swap that node. Okay, clear? Clear this? We insert 30 here, but check the parent node is greater than child node. No, then swap these two elements. Then after swapping this, check one more time. So here also not follow the property of the max heap, right? So then swap these two elements. So finally we make this max heap tree. So what is in array? How the elements are present inside the array? First write the parent node 30 and left and right child of parent node, and then left child children 9 and 15. Likewise we add the elements inside the array. Okay, then perform the delete operations. So on over, build the max heap and delete element from max heap. Okay, delete first element from array, and how to update in the tree. So what is the first element in the array? That is 30, right? So this is the tree structure. We now remove this element 30 from this tree. Then update it with last element. Okay, we will delete first element from the array. That means first element in the tree, and then add the last element in that deleted portion. Okay, clear? So here we deleted 30 here. Now this place is empty. Then we add the last element in the tree into this place. So what is the last element here? 15 is the last element, right? Left then right. So 15 is the last, then update this element in this portion. Yeah, so the tree will change like this. Then so every time we check the particular tree follow the max heap property. Then we check it out. The parent node is greater than child node? No. Here 15 is less than 20. Then swap these two nodes. Okay, you not follow the property, this swapping will perform. So 20, 15. Now check one more time. Here 9, so parent is 15, no problem. Here child is 15 and 17. 20 is higher than the child, so no problem is there. Okay, so in array, so we insert 15 to 30. Okay, so remove 30 from the first position and insert 15 in this position, and the last position will empty now, right? Then add this deleted element in the last portion of the array, because the 15 is moved from here to there, right? Then this portion is empty, so the deleted elements will insert in this position. Clear? Clear? Then so this is not in correct order because the parent node is less than. So after updation we change the order in the array also. Okay. Then now this is the tree structure, right? Then delete the next element. Now the first element is 20, right? Then delete this element from the tree. Then add the last element in that position. So now which one is the last? 9 is the last. So update 9 in this position. Clear? So now 9, 15, 7. Then check the max heap property. Here 9 is less than 15, right? So then swap these two variables. Swap these two variables. So now this is the max heap. Then update the array also. So now the first element is 20 is deleted and placed into last position, because this position, so 9 already in this position, right? So 9 present here, so 20 is present in this position. Likewise we update in tree updation, likewise we update in the array also. Okay, then after, so this is the array, then element next element, that is the, now the first element is 50, so delete from the tree. Then update with the last element. So we delete first element and replace the first element with the last element, right? So which one is the last element? Right child element. Okay, so update this with this. Then check the max heap property. Here 7 is less than 9. Okay, so update it. Swap these two variables. So 9, 7. This is max heap. So update the same in the array also. We shifted 9 from this place to this place. And now this place is empty. We just insert the deleted element in this position. Clear? Deleted position in this position. Okay. Then finally 9, 7. What is the first element? 9. What is the last element? 7. So updated with the 7. So now 7 is in the first position. This place is empty. The deleted element insert in this position. So finally we got the sorted array. Clear? So in heap, so array is given using we sort the array in descending ascending order using Heapify method. Heapify method we need first we build the max heap tree structure, and then delete the element one by one from the tree. Finally we got the sorted array. Okay. So two important things are there. One is we insert the node in the tree in the correct order. Okay, we insert the node, the tree in correct order. First parent node, then left, then only right. Okay, and another one, in every time you add one new node in the tree, then check the max heap property. So in max heap, always the parent node is greater than child node. Otherwise, you swap these two nodes. Okay, these two are very important thing to build the max heap tree. Okay, then find the delete operation. So delete the first element and replace that element with the last element. Likewise, we updated in the array also. So finally we got the, so in every delete operation, the last element is placed in the highest element placed in the last position. Second highest element placed in the previous position. Likewise, so after every deletion we sort the array likewise. Finally we got the sorted array in this manner. So in deletion operation also, in every time you delete one node from the heap tree and updated that node with another one, the last element, then only we must check the particular tree structure follow the max heap property or not. If the parent node not greater than the child node, we swap the parent and child node. Always make the parent node as greater than the child node. Okay. Clear? So this is the heap chart. Have any doubts in this heap chart? Write it in the comment section. Thank you.